Laboratory tests for the diagnosis of PNH. The laboratory tests include ham test, sucrose lysis test, cephaloacryl gel card test, flow cytometry. The first one is ham test. Ham test is also called as acidified serum test. First, it was described in 1937. The principle says that the red cells of normal people do not lyse when exposed to group specific or AB serum at a suitably acidified pH 6.5 to 7 at 37 degrees centigrade. Red cells of patients suffering from PNH when treated in similar manner tend to lyse because they are very susceptible to lysis by complement at an acid medium. So, Ham's test is based on acidic medium. The addition of magnesium chloride enhances the principle in the basis of the Ham's test. So, this is Ham's test. Here, patient's red cell can be obtained from a defibrinated blood, or you can even use a heparinized blood, oxalated, citrated or EDTA blood can also be used. Preferably we go in for a defibrinated blood. What is the procedure for defibrination? What is defibrination? First of all, defibrination means removal of fibrin threads from the blood sample. So if fibrin threads are removed, the blood do not clot. So that blood is called as defibrinated blood. How do you defibrinate the blood? The blood is taken in a conical flask, and to that we add about 8 beads, glass beads. Each glass bead is about 2 mm in diameter. We take those glass beads in the conical flask. To that we add the blood sample. The collected blood sample is added and you swirl. Plug the conical flask with the cotton and you swirl. Swirl is just rotate it over a uniform surface. By doing this for about 20 to 25 minutes, all the fibrin threads gets attached to the glass beads and the blood becomes defibrinated blood. The glass beads are separated and you get a defibrinated blood. This is the procedure for defibrination. That is the one reagent what we require. The other reagents required are, you require fresh serum which is compatible with the blood group of the patient to be tested. That is same blood group sample, fresh serum is required. Second one, you require a inactivated serum. That is the same serum can be taken 2 ml and it is placed at 56 degrees centigrade for 30 minutes. This will inactivate the complement. And other things what you require are HCl for acidification of the test. That is 0.2 mole per liter HCl solution is used. Normal saline 9 gram per liter sodium chloride is used. Drapkin's solution is required. Magnesium chloride solution, that is 250 millimole per liter magnesium chloride solution is required. So these are the requirements for the test. Now coming on to the test. This is the present slide. What you are seeing is the basic structure of the test. So here it says the complement present in the serum is responsible for the lysis of the PNH cells with sensitivity to acidification. So patient's red cell is mixed with the fresh complement. Same way even the control sample is also done. Suppose there is lysis, then it is called as PNH. Suppose there is no lysis, it is called as a normal blood or lack of PNH cell is set. Here in between we also do the acidification. Now this is the control tubes, the same method as I showed there. Here no lysis is seen. Now Now we'll come into the detailed explanation of the test. Now first you have to prepare the red cells for the test. So 2 ml of blood from the patient and control is taken. It is washed, both patient and control are washed for about 2 to 3 times with normal saline, and the final suspension is prepared. Washing is for about 2 ml of the blood, 3/4 of the test tube is filled with the normal saline in the test tube. Then you centrifuge it. When you centrifuge, you get a sediment and the supernatant. The supernatant will contain all the other plasma factors which is not required. We want only the red cells. So the supernatant is discarded, what is not required. To the sediment red cells again saline is added, mixed, that is saline is added till the 3/4 of the test tube, mixed and again centrifuged. The tube is centrifuged. Once you centrifuge, you get again 2 layers there, the sediment and the supernatant. Discard the supernatant. This way you proceed for 2 to 3 times. On the last wash you discard the supernatant completely. The sediment what you get, add equal volume of saline. Measure the sediment and add equal volume of saline. So that gives you a red cell suspension, 50% red cell suspension. Serum should be compatible. Next is serum required. Serum should be compatible with red cells being tested. That is 2.5 ml of fresh serum and 1.5 ml of inactivated serum at 56 degrees centigrade for 30 minutes. I have already told how inactivation is done. 56 degrees centigrade for 30 minutes. So red blood cells are we have kept ready. We have kept ready the serum. Now you are going to take 6 test tubes as shown in the slides. 6 test tubes and label them respectively. 1, 2, 3 as for test and 4, 5, 6 as for control. You are going to label them, and respectively you are going to add the reagents. That is fresh normal serum what you have collected and kept, 0.5 ml to test tube 1 and test tube 2, 0.5 ml of control sample to test tube 4 and test tube 5. Next, inactivated serum is added to test tube 3 and test tube 6. 0.2 millimole per liter HCl is added to test tube 2 and 3. Similarly to test tube 5 and 6. 50% red cell suspension what we prepared is added to all the test tubes. That is patient's 50% red cell suspension to all the test tube 1, 2, 3. Similarly 50% normal red cell suspension is added for control tubes 4, 5 and 6. Now magnesium chloride 0.01 ml is added to all the tubes. 1 to 6 tubes are added. After the addition of all these reagents, place all the tubes at 37 degrees centigrade in water bath for about 1 hour. Remove the tubes from the water bath and centrifuge at 2500 rpm and take reading in a colorimeter or spectrophotometer. Now in the test, as I told in the principle, here what the reagents what we are adding will give you the results. Now in the test tube 1 what we have added patient's normal serum and patient's red cells, right? And in test tube 2 we have added patient's normal serum and we have added patient's red cell, and we have also acidified in test tube 2. In test tube 3 we have not added patient's serum, so group specific serum is not added, but we have added inactivated serum. We have acidified the tube and we have added patient's red cell. Similarly in the control tube also. So tube 1, if you have to see, in tube 1 what is missing? Acidification is missing. We have added normal serum, we have added patient's red cell also. In tube 2 normal patient serum is there, and not patient serum, normal serum, group specific serum is there, patient's red cell is there, and acidification is also there. In tube 3, there is no normal serum, group specific serum is absent, patient's red cell is there, acidification is there, inactivated serum is there. Instead of group specific serum, inactivated serum is there, right? So next we'll continue with the observation part. Observation. If there is lysis, if there is visible lysis in tube 4 to 6, then the test is invalid. 4, 5, 6. In all the 3 tubes, if you get visible lysis, it is invalid, because in we are not supposed to get agglutination here, because we are not supposed to get lysis here, because we have used here group specific serum, right? So no agglutination is seen. Since all the 3 control tubes should be negative. If tube 1, 2, 3 show lysis, check whether the serum what you have used is a proper valid serum or not. Because tube 3 you are not supposed to get lysis, because we have used an inactivated serum. If only tube 1 and 2 shows lysis, or tube 2 and 3 shows lysis, then you can continue and take the reading. Coming on to the reading part. For reading, these measurements must be kept ready. That is the blank. You should keep ready 100% patient's reading, 100% normal control sample reading, and test reading. These readings must be kept ready for moving on to the calculation part. So how do we take the blank reading? For blank reading, 0.3 ml of normal serum is diluted with 5 ml of Drapkin's solution. 100% patient, next is 100% patient, 0.05 ml of 50% patient's RBC suspension is diluted with 0.55 ml of saline. Mix this content, and from this you take 0.3 ml and dilute with 5 ml of Drapkin's solution. Wait for about 5 minutes and take the reading. That will give you 100% patient. Similarly, 100% normal control sample, instead of patient red cell control suspension, you add a normal control suspension and take the reading. For test, you take 0.3 ml of the suspension of each of the 6 test tube and dilute with 5 ml of Drapkin's solution. Wait for 5 minutes and then take the reading. Now keep ready all these readings and proceed with the calculation part. For calculation, percentage of hemolysis is calculated, that is test minus blank reading divided by 100% reading minus blank reading into 100. Now this 100% reading is, suppose you are taking the reading of test tube 1, then you will have to put the 100% patient's reading. Similarly, next again calculation, test tube 2, you have to put 100% reading of the test tube 2. Next, test tube 3, third calculation. Similarly, when you come for control samples, the 100% reading will be of that of the control sample. Same way, do the calculations. Now, you get a negative result. A negative result should show no lysis. That indicates negative result. If it is a positive result, then tube 1 will show a trace reaction, trace lysis, sorry. Tube 2 will show 3 plus lysis, and tube 3, 4, 5, 6 will show no lysis. Usually if this reaction is shown, then it is because of hereditary spherocytosis.